In this episode, we take a topic that can sound intimidating at first and make it practical. Building an AI risk metrics dashboard that helps people make better decisions instead of drowning them in numbers. Many beginners hear the word dashboard and picture a wall of charts that looks impressive but does not actually change how anyone behaves. That happens when metrics are chosen because they are easy to count, not because they are useful for managing risk. A good dashboard is more like an instrument panel that highlights what is going wrong, what is trending in the wrong direction, and what deserves attention before it becomes a crisis. It also helps create shared awareness. So the conversation about AI risk is based on evidence rather than feelings or headlines. By the end, you should understand what a risk metrics dashboard is really for, which metrics are worth tracking, and which ones often waste time or create false confidence. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A dashboard only works when it is tied to decisions, so the first step is to decide what decisions the dashboard is supposed to support. In AI risk governance, common decisions include whether a system is safe enough to launch, whether it should be constrained to a smaller scope, whether a control is working, and whether a model update should be paused. If a metric does not help with one of those decisions, it is probably not dashboard material, even if it is interesting. This is where beginners often get stuck, because it is tempting to treat metrics as a general report card rather than a decision tool. When you treat it as a decision tool, you naturally prefer metrics that are sensitive to risk changes and that give early warning. You also prefer metrics that someone can influence, because a metric that cannot be improved by any action becomes a source of frustration rather than learning. To make the dashboard trustworthy, you need a clear definition of what counts as an AI risk signal. A signal is a measurable observation that suggests a risk is increasing, a control is failing, or a harmful outcome is becoming more likely. Signals can come from system behavior, like error patterns, output quality, or unusual spikes in certain kinds of responses. They can come from user behavior, like increased overrides, repeated reprompts, or a surge in users flagging outputs as unsafe. They can also come from organizational outcomes, like customer complaints, incident tickets, legal inquiries, or reputation hits. The dashboard does not need to capture everything, but it should capture signals that connect to real harm. When signals connect to harm, leaders treat the dashboard as useful rather than decorative. A practical way to choose metrics is to group them into a few types that cover the life cycle of AI use. One type is exposure metrics, which tell you where and how the AI is being used, because risk depends heavily on the context of use. Another type is performance and quality metrics, which tell you whether the system is behaving as expected in ways that matter to the use case. A third type is safety and harm metrics, which capture outputs or outcomes that indicate risk of real harm, such as sensitive data leakage or unsafe guidance. A fourth type is control effectiveness metrics, which tell you whether safeguards like human review, access restrictions, or monitoring are actually working. Finally, there are response metrics, which capture how quickly and effectively the organization reacts when a problem is discovered. A beginner-friendly dashboard usually includes a small number from each type, rather than trying to track hundreds from one category. Exposure metrics are often overlooked, but they are critical because they help you interpret everything else. If the usage of a system doubles, then a stable number of incidents may actually mean risk is improving per unit of use, or it may mean problems are being underreported. Exposure metrics can include the number of users, the number of interactions, the number of use cases enabled, and the categories of decisions or content the system touches. They can also include where the system is deployed, such as internal only versus customer-facing, because that changes the reputational and legal impact of failures. The point is not to obsess over popularity, but to understand how big the surface area of risk is. A dashboard without exposure metrics is like tracking car accidents without knowing how many miles were driven. Performance and quality metrics need careful handling because AI systems can look good on average while failing badly in specific situations. For many AI uses, especially generative systems, Average accuracy is not the only concern. Consistency and reliability in high-stakes scenarios matter more. Useful metrics can include the rate of outputs that require correction, the rate of user overrides, and the frequency of certain failure patterns like irrelevant responses or contradictory answers. You can also track trends over time, because drift is often gradual, and a weekly pattern can reveal a slow decline that a single snapshot would hide. The key is to tie quality metrics to what the user actually needs, not to abstract model scores that do not match real-world use. If a metric cannot be explained in plain language to a new learner, it is probably too far removed from practical risk management. Safety and harm metrics are where dashboards often either become extremely valuable or extremely misleading. Valuable safety metrics focus on concrete harm categories, such as outputs that include sensitive personal information, outputs that provide unsafe instructions, outputs that contain hateful or discriminatory content, or outputs that mislead users in a way that could cause real damage. Misleading safety metrics are those that create a false sense of safety, like a generic safety score that nobody understands or a count that is easily gamed. Another challenge is that harm is not always captured by the system itself, because some harms appear later, such as unfair outcomes in decisioning or reputational damage from a viral incident. That is why it is important to include downstream signals like complaint categories, escalation rates, and reported adverse outcomes when those are relevant. A good dashboard shows both what the system is producing and how the world is reacting. Control effectiveness metrics are often the most important because governance is about whether controls reduce risk, not just whether risk exists. If you require human review for certain outputs, you can track the percentage of those outputs that actually went through review and the percentage that were modified or rejected. If you restrict access to sensitive data, you can track attempted access violations and whether restrictions are being bypassed through informal workarounds. If you have monitoring alerts, you can track whether alerts are reviewed, how quickly they are triaged, and how often they were true positives versus noise. These metrics tell you whether controls are alive, because a control that exists on paper but is ignored in practice is not a real control. For beginners, this is a powerful lesson because it shifts focus from intentions to outcomes. Response metrics matter because even the best controls will miss something, and what defines maturity is how the organization responds when that happens. Useful response metrics include time to detect an incident, time to triage, time to contain, and time to close out with remediation. You can also track recurrence, meaning whether the same type of incident happens again after a fix, because repeated recurrence suggests the fix was superficial. Another useful signal is the percentage of incidents with a completed root cause analysis and an implemented preventive change, because that shows whether the organization learns. These metrics encourage a culture where incidents become learning opportunities rather than blame events. They also help leadership invest in the right areas, because slow response often indicates gaps in staffing, process clarity, or monitoring quality. Now we can address what to ignore, because dashboards fail most often by including metrics that are tempting but unhelpful. One common trap is vanity metrics, like the number of AI features shipped or the total number of model interactions, when those numbers do not connect to risk. Another trap is overly technical metrics that are disconnected from harm, such as internal model training statistics that do not translate into user impact. A third trap is metrics that create an illusion of precision, like a single risk score that combines many factors into one number without clear meaning. Another trap is measuring everything that is easy to measure, such as counting policy acknowledgements, while ignoring what is hard but important, such as whether people actually follow the policy. When you ignore these traps, you create a dashboard that invites action rather than debate. Dashboards also need thresholds, because a metric without a trigger is just a fact. A threshold is the point at which a metric change requires a response, such as opening a review, applying a constraint, or pausing a release. Thresholds should not be chosen randomly, and they do not need to be perfect on day one. They can start as simple escalation rules, like any confirmed sensitive data exposure triggers immediate containment and a leadership notification, or any sustained increase in unsafe output flags triggers a deeper evaluation. Over time, thresholds can be refined based on experience and risk appetite. The important part is that thresholds turn measurement into governance, because they define when the organization stops watching and starts acting. Without thresholds, dashboards become passive, and passive dashboards do not prevent harm. Another key point is that dashboards should be designed for different audiences, even if the same underlying data supports them. Executives generally need fewer metrics, focused on exposure, harm trends, and decision triggers. Risk and governance teams may need more detail about control effectiveness, incident patterns, and lifecycle status. Operational teams may need granular signals that help them fix problems quickly, like which categories of outputs are being flagged. If you try to satisfy every audience with one screen, you often end up with a cluttered mess that satisfies nobody. A smarter approach is to keep a small core set of shared metrics, and then allow different views that highlight what each group needs to do their job. This keeps the dashboard aligned with action rather than turning it into a confusing compromise. To make dashboards reliable, you also need to think about data quality and what your metrics actually mean. If users do not report issues, a low incident count might reflect silence, not safety. If a monitoring system produces too many false alarms, teams may ignore alerts, which makes detection time look good on paper while real issues slip by. If definitions are inconsistent, like what counts as a harmful output, trend charts may be misleading because the categories changed rather than the system behavior. This is why good dashboards include stable definitions and periodic checks on measurement integrity. The dashboard itself should not become a source of false confidence, because false confidence is one of the most dangerous risk states. A trustworthy dashboard is humble, meaning it shows what it can show and it makes limitations visible through context and notes in how it is used. As we wrap up, the main lesson is that AI risk metrics dashboards are not about collecting data for its own sake, but about guiding decisions with signals that connect to real harm and real controls. You choose metrics by starting with the decisions you need to support and then selecting exposure, quality, safety, control effectiveness, and response signals that make those decisions easier. You ignore vanity metrics, overly technical numbers that do not map to harm, and fake precision scores that hide meaning behind a single number. You set thresholds so metrics trigger action, and you design views that match the needs of different audiences without overwhelming anyone. Finally, you protect the dashboard's credibility by caring about data quality, stable definitions, and what the absence of signals might actually mean. When you build dashboards this way, they become a living part of AI risk governance, helping the organization stay focused on what matters and avoid wasting attention on what does not.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.